They're saying rewrite the following as a decimal number. All right, so they're just pointing out the place value. Here, let me, rather than do that one right now, forget about that question. Let me just write a number out here. 73, that's too big. Let's just start with 3. 3,486, that's a 4 there, 0.27. All right, let's talk about place values. You know about place values. You guys are pros at this after all that foreign base system stuff we did, huh? So let's start with the 6. The 6 is in what's place? The ones place, huh? The 8 is in the tens place. The 4 is in the hundreds. See, it just goes up. You just multiply by 10 every time because we're in a base 10 system. You know deeply what that means now, right? That we have a base 10 system. The 3 is in the thousands, right? So when you go from place to place, you just multiply by 10. Remember us doing that in other bases? Right? So this is the ones times 10 times 10 times 10. So you know all about that. So now, one way you could write that, 10 is 10 to the 1 power, of course. What's 100? 10 to the second, if you wanted to do it with powers, right? And 1,000 is 10 to the third. Basically, the number on the 10 is the number of zeros, huh? Right? 10 times 10 is 100. You know, the 2 zeros, 3 zeros, 1 0. What about 1? That's 10 to what power? 0, yeah, remember anything to 0 power is 1? Okay, now what comes next? Let's keep following the pattern. What's next? Well, the 2 is in the what's place? Tenths. Yeah. Tenths, which means 10 to what power? Negative 1. Yeah, of course it's got to be by the pattern, right? 3, 2, 1, 0, negative 1. And in fact it is. Tenths means 1/10, doesn't it? Remember negative powers flip things? You remember that from algebra? So that makes sense. And that is the tenths, right? This is 2/10, isn't it? See how that all fits perfectly? Don't you love the way math always works? As long as we're consistent. The truth of fractions, the truth of powers, the truth of names for places, it's all perfect fit. Perfect fit. So, and then next, what's the 7? The 7 is in the hundredths, right? Which means 10 to the minus 2 because that's 1 over 100. So the negative powers, that tells you how many zeros on the bottom. Negative powers go to the bottom. Remember that? Negative powers flip things. So anyway, so with that in mind, let's get back to the question. So they're saying, hey, we got a number here, 4 times 10 to the third. So what is that? 10 to the third. Remember that means 3 zeros. So that's 4,000, isn't it? So that's 4,000. Oops, that 4 looked bad. 4,000. What comes next? 3 times 10 squared. What's that? 300, right? Because the 2 is 2 zeros. 4,300. Okay, next. 3 times 10. 30. 30. Next. Whoops. Jumping all around. Next is just a 1, huh? Just a 1, like that. All right, keep going. 9 times 10 to the minus 1. That goes after the decimal. That's 9/10, right? That's 9 times 1/10. Right? 9/10. That's 0.9. 9 in the tenths place, huh? When you go to the right of the decimal, it's tenths, hundreds, thousands, isn't it? And lastly, 1 times 10 to the minus 2, that's 1 over 100th, right? 2 zeros in the bottom, that's what the negative 2 power does. 2 zeros in the bottom, so that's a 1 there. It's like a rainbow number. 4,331.91. That's the decimal. You don't have to do all that stuff, but all you have to do is write this however you get there. We good? 4,331.91? All right, let's try. It's coming on down here. Speak up if you have questions on anything. 300 30 and 6/10. Can you write that out as a normal number? Just practice reading the words there. Just write that as a normal number. So 330 and 6/10. What do I do with that? 0.6. Because it's 6 in the tenths place. So there we go. Is that good? All right, let's try number 3. Now, let me show you number 3. If you're good, I'll keep. All right, 0.025 in words. 0.025 in words. So which one of those, so let me let you read those and think about those. There's multiple choice, you know. Which one of those is right? I'll give you a second on that. So here I'll label them A, B, C, D. What do y'all think? Nobody knows? B? 500,000. Here, let me ask you, what would you call that? How would you say, I mean in words? You'd call it 7 what? Tenths, correct. Now, what if we went 0.07? You would call that 7 hundredths. Now, notice what you're doing. You're giving the name of the last place, aren't you? And that's correct. You're right. So right, because this is the tenths place, but you didn't say tenths. You said the last place, which is hundredths, and you're right on the money. So therefore, that is how you name a decimal. So this is the what's place? Tenths. I write tenth. This is hundredths, and this is thousandths. So what's the answer? A. 25 thousandths, huh? You name it by the ending place, don't you? Name it by the ending place. 25 thousandths. Good there? Making sense? All right. What's a terminating decimal? What's that? Prime number, not 2 or 5? You're thinking right about the 2 and 5 thing. First off, just what's a terminating decimal, though? What does that even mean if somebody says, you're giving, Asen, you're right on track with the deeper reason, and we'll get there in a second. But first off, just the simple thought, what do they even mean by that word, a terminating decimal? An end, yeah. Terminating means ending, right? Right? So yeah, terminating means a decimal that ends. It ends. So that would be like 0.429. That's a terminating decimal. So then what's a non-terminating decimal? Well, it doesn't end, right? Does not end. So, do you know any numbers? Like decimal numbers don't end? Yeah, like 10 divided by 3. Right, or just 1 divided by 3. Just make it even simpler. Yeah, totally. That the 3's go on forever, huh? Don't they? Yeah. Yeah, so decimals that go forever are called non-terminating, non-ending, and terminating ones end. Okay, so what they're asking is they're saying, hey, how do you know which fractions become decimals that end and which ones don't? And what's the rule, Aislan? Does what?
Oh, then if it's a 2 or a 5, then it's a terminating decimal, but if that has anything other than 2 or
How do you like know that? That's not something people commonly know.
I just did the homework right now.
Oh, okay. Yes, you're totally right. Good job. Yeah, I mean, it's kind of weird. But you were right on the money. Let me write it out. Yeah, so basically, if a fraction, I'm thinking, wow, nobody knows that ever. If a fraction has only 2 or 5 in the denominator, then it'll end. When you make it a decimal, the decimal, it ends. So, well, I'm not giving quite the whole story. A fraction, I should say, reduced. So you'd have to reduce. First reduced. So if it's a reduced, meaning if you had like 2 over 6, you'd have to first make it 1/3. You know what I mean? So you have to reduce it first. So if you have a reduced fraction, and it has only 2's or 5's, I should have said it that way. If it has only 2's or 5's in the denominator, then it ends. And I'll go over here. If it has any primes other than 2 or 5, then it does not end. It's an everlasting decimal. Goes on and on and on. So so that's the deal. It's all about only 2's and 5's, then you're going to end. If you have any other prime numbers, 3, 7, 11, 13, all the other primes, you're not going to end. So, whoops, sorry, that's too quick. Get that copy down. So, let me go up here then and give some examples. We'll just do a couple examples and we'll stop. We'll not quite make it through this section, which is fine. You all didn't want more homework for the weekend anyway, I'm assuming. Okay, so like what I'm saying is, like the 1/3, we already gave the 1/3, right? That one goes forever, and the reason is because it has a number in the denominator other than 2 or 5. So if you have a number like 1/2, what's that? 0.5, huh? That ends, doesn't it? What about 1/5? It's actually 0.2. What about 1 over 2 times 2 times 5? Am I saying that will end? Yes, it will. Just got 2's and 5's. It's 1/20th, right? Somebody have it on a calculator? Oh, I know it. 0.05. It ends. Now, why? Why do 2's and 5's only? That's okay. Like, so notice if I say, what if you had a number like 1 over 14? Do you think that fraction, if you took your calculator right now and went 1 divided by 14, do you think you're going to get a decimal that goes forever or that ends? If you broke down that 14, it's 2 and 7, right? So that's really 1 over 2 times 7. So what's it going to do? Forever. It's going to never end. Somebody have it? What is it? What's 1/14? Point. One more time?
It's 0.07.
142. Yeah, goes on and on and on. No. All right, well, I'm going to leave you with that question for the weekend. Think about nothing else this weekend, but about why 2's and 5's are so